Let's have our look at the calendar. Thank you guys so much for coming. We've got almost everybody here, day before Thanksgiving. Well done. Today is our third out of 4 days on finances. Today we cover consumer debt, specifically credit cards and mortgages. All right, 2 different ways that we can end up having debt. And we'll talk about exactly what those things mean. And then next class on Monday when we come back after break, saving for retirement. And that'll be our last class on finances. The project is officially assigned today, but we've already had a little bit of time in the last 2 classes to work on it in class. So you guys are all ahead of the game at the moment. So hopefully you keep on working on that project. It is due on December 9. Questions on the calendar? Okay, then let's begin here on page 13. And we'll get our reader. Let's go to, where are we here? Mary, can you read the first thing on 13? Okay, thank you. If you guys don't mind sharing, can I get a show of hands if you own a credit card? If you have a credit card? Okay. Debit card is okay, yeah. All right, so we've got just about everybody covered with a credit card or a debit card. So probably you guys know most of the basics about it, but we'll just begin at the beginning here. Evan? Okay, so that's the key. And in fact, that line right there is why credit card companies stay in business, is because they make money on this finance charge. So let's say that I go out and I buy a television today, and then I pay my credit card bill in like 3 weeks when it comes due. As long as I pay for that television in full 3 weeks from now, I pay for the television exactly what the price of the TV was. I pay nothing more. As long as you pay things in full by that due date, you pay no interest. But as soon as I don't pay off things in full, I start to pay interest on all future purchases and the television itself. So until I get my entire balance down to 0, I'm paying interest on everything that I buy on credit, okay? That's a dangerous thing. Evan, the last bullet. Okay, so we'll look at each of these things in detail here, and then we'll start doing some calculations. Brandon, 2. Okay, so here are 3 formulas that you're going to have with you in front of you on the homework and on the test as well. Periodic interest rate. Periodic, that just means like, so the period in this case is daily. It's a daily interest rate that you get charged. So they take a look at the number of days in a particular month and they divide by 365. So if it's, what month are we in now? November has 30 days. So they would take the APR, like let's say they say the interest rate is like 19.99% because they don't want to frighten us with the number 20%. All right, so let's call it 20% interest. So it's a 20% interest rate. They're going to cut that into 12 months, but the months are not equal. And so they're going to account for the fact that February is shorter than December by counting days. So they'll take how many days in the month? In this case, it's 30 for November, divide it by 365, multiply that by 20%. Can we actually do this real quick for us? Let's suppose that we do 30 days in the month, divide by 365, times the APR, which is 20%. Right away, we convert that to a decimal. What do we get here? Damien? Okay, so about 1.6% interest for the month. The month of November would have 1.6, I'll write one more digit, 1.64% would be the amount of interest you pay in November. In December, would the interest be a little bit less or a little bit more? A little bit more because there's an extra day in December. January would be the same as December. February would be less because there's only the 28 days. Okay, so that's how they calculate your interest rate per month. It's all basically going to be that number, but it'll change a tiny bit month to month. To calculate how much you owe, It's complicated. They're gonna hit you with this 1.64%, but your balance changes, right? Like your balance could change on a day-to-day or even an hour-by-hour basis. If you buy more stuff, you buy something today, and your balance today is bigger. If you don't buy anything for the next 2 weeks, your balance stays the same. Then you buy something else, and your balance goes up again. So they're going to look at how much money you owe them at the end of each day, and they're going to calculate this thing called the average daily balance. They'll look at how much you owe every single day of the month. They'll add them all up. So let's suppose that my TV is $200 and I buy nothing else. So I owe $200 on the day I buy the TV. I still owe $200 the next day and the next day and the next day. We're going to add up a lot of 200s. And then we're going to divide by the number of days in the month. Now, if I don't buy anything else other than my $200 TV, what will I get when I add up all of these 200s for November and then I divide by 30 days in November? What will we get? If you add 200 for November 1st, 200 for November 2nd, 200 for November 3rd, all the way up to November 30th, and then we divide by the 30 days, we're going to get 200. My average daily balance will just be straight 200. But if on the last day of the month I buy, like $1,000 laptop, my balance is going to go up, but just for that one day, right? They're not going to hit me for the entire month if I only buy the laptop on the last day. So they add up all the balances every day, divide by the number of days in the month. It will tell them how much you owed them on an average day. And then they're going to calculate their finance charge. This is their profit. They'll take the interest rate that we found up above, 1.64, multiply it by how much you owed them every day, say $200, and that will be the finance charge, the interest that you owe them for the privilege of buying that TV before you actually paid for it. Okay, let's take a look at this example. We can go to Aileen. Thank you, Lila. Thank you. Okay, so here's the deal. You were good about paying off your credit card in full until this cycle right here, and you bought $1,000, but you can only pay $300. So you pay no interest until that point. But now because we have a $700 balance that we're carrying over, we're going to pay interest on everything. We're going to pay interest on the $700 that we haven't paid off yet, but we are also going to pay interest on these last minute gifts. The day that we buy them, we're going to start paying interest on them. And we're going to pay interest on that Gatorade the day that we buy it. So what we're going to do is calculate what our bill is going to be at the end of all these purchases, which includes some very complicated calculations to figure out what that interest is. That's what we're going to do here. Okay, first thing is pretty straightforward actually, is calculating the periodic interest rate. So all we have to do is follow our formula up here. So remember, periodic interest rate, number of days in the month, divided by 365 times the APR. Okay, we are looking at the cycle December 20th to January 19th. Okay, it actually makes no difference whether you think about December or January because they happen to have the same number of days, but usually that's not the case. Which month is the important one in terms of calculating how many days there are between December 20 and January 19? So you could just sit and look at a calendar and start on December 20th and X off all the days until January 19, and you can count the number of days. But it's easier than that. Which month is the one that we're crossing over, that we're finishing? Is December. We're finishing the month of December. How many days are in December? 31. That's how many days there are between December 20 and January 19. Again, you can sit and look at a calendar if you want to. But this is a month-to-month cycle, and we are crossing over December 31st. That's the magic number, all right? So 31 days in December divide by, what's next in the formula? 365, always. Multiply by the APR as a percentage. In this problem, it was 19.99%. 0.1999. So let's calculate. At some point, we will round it, but let's write a few digits here. Yeah, what do we get? How much? 7. Okay. All right, so that's probably good enough. So then we'll say that this is, well, it's actually fine to leave it there. It's about 1.7%. But when we do the calculations, we'll use this number with all 7 of these digits here. Okay, now the hard part. That's the easy part. The hard part is calculating the average daily balance. How much did we owe coming into this month, coming into this cycle? 700 coming into the cycle, right? Because we bought 1,000 and only paid 300. Okay, so starting on December 20th, we owed 700. How much did we owe on December 21st? 700. December 22nd, 700. December 23rd. Changes. It's more, right? Okay. So here's what we're going to do. Between December 20th and December 22nd, because on the 23rd we bought something, we owed the same amount of money. So I'm going to make a little chart here. Actually, I'm going to squeeze this over, give myself a little bit more room. December 20 to 22nd, I'm going to write down up here the number of days, and I'm going to write over here the balance. Okay, for how many days? Is it 2? December 20, 21, 22. It's 3 days. How much did we owe for each of those 3 days? 700. So when we do this average daily balance, it says you find the sum of all the daily balances. So far we have a 700 plus a 700 plus another 700. Excuse me. Thank you. Do you guys see what we're going to do with those numbers instead of adding 700 plus 700 plus 700? Yes, we will do that in the next line. But just with the 3 and the 700, we're going to multiply those. It doesn't say multiply in the formula. It says the sum of all the daily balances. But instead of writing out 700 plus 700 plus 700, we're just going to say, oh, it's just 3 700s. So we're going to multiply these. Okay, the next important period here starts on December 23rd. That's when our balance changes. And it goes until the last day of December, which is the 31st. Because on January 1st, we bought something else. You got to chase the Tylenol with something. Be very careful. How many days are there counting the 23rd up to the 31st? There are 9 days. It's so tempting to subtract and say 8. Look at a calendar. You'll find out that it's 9. It's always one more than you think. So feel free to subtract, but you got to add 1. I'll show you a quick check for that later on. So this is 9. Now we carried a $700 balance, but we also bought some last minute gifts. So we're going to add, we're going to get $834.76. Everybody see where that number comes from? All right, with your neighbors, I would like you guys to fill in, 2 more rows, because there were 2 more transactions in this month. So fill in the next 2 rows. Okay, let's come back together. So there's like 2 columns that we filled in, the number of days and the balance. I think the balance is pretty straightforward. You're just adding however much you bought. It's the number of days that tends to trip people up. The next period was January 1st to January 9th, because on the 10th, our balance changed. How many days is that? It is 9 days. You can subtract. I mean, this one's pretty easy because it just goes from 1 through 9. That's 9. But if it's not easy, you subtract. And you get 9 minus 1 is 8, and then you add 1. Just always add 1 as a rule. That's 9. This billing cycle ends on January 19th. That's going to be in the problem. How many days are there there? There are 10 days. Looks like 9. It's 10. Okay, as a quick check, I promised you guys there would be a way to check. Add up the number of days. 31, which happens to be exactly how many days there are in December. It has to work that way. Right? If you don't get something that is the same as the number of days in the month that completed in the cycle, you did something wrong. Okay, again, coming back to our formula. Average daily balance, we're supposed to add up all the daily balances. The first balance is 700. On the next day, it's still 700. On the third day, it's still 700. We're adding them up and we get 2100. But we decided that the easy way was to do what with these numbers? Just multiply them. I don't have any space here. I hope you guys do. We need to multiply straight across all 4 of these pairs of blue numbers. So I'm going to write this over here, but this isn't really where it belongs. It belongs in another column over there. Right, so these are our partial sums of the daily balances. We need to add them all up. Somebody add all this stuff up. Tell me what we get. Mary? Thank you. Okay, that is a scary big number. What does that $26,000 mean? Yeah, it's the total of all the daily balances. We don't owe 26 grand, but over the course of 31 days, we owe 26 grand. How do we find out how much we owe each day? Divided by the 31. And I'll just remind you, this is just part of our formula. We were doing this average daily balance. It says find the sum and then divide by the number of days. Okay, so we'll take this guy, divide by 31. And what is it again? 8. Is that a reasonable answer? Looking at the chart we made? Yes, that's very reasonable, right? We know we started with 700, we ended with 892. You better get some number in between those. 844 seems great. Okay, so essentially we owed them $844 every day of the month on average. They're going to charge us an interest rate of basically 1.7% for the month. What are we going to do with those two numbers to find the actual interest that we owe? I said 1.7%. It's really this 0.0169. What are we going to do? We have two numbers. Yeah, it's this much that we owe. That's the interest rate. We're going to multiply them. Again, I'll remind you that the finance charge formula just tells us to do exactly that. Take the periodic interest rate, 1.69, multiply by the average daily balance. Alicia? Okay, so let's round it to the nearest penny. 34? Okay. So our finance charge is $14.34, which might not be that scary, but there are really smart people out there that owe tens of thousands of dollars, not $800. And when you owe tens of thousands of dollars, the numbers become really scary. Questions on the calculation? Okay, when we're ready, we move on to the next page. Wait for people to finish copying. Okay, so this one here says let's calculate the new balance that's going to appear I want to throw one other wrinkle into this problem. Can we just add this real quick? On January, what was it, 19 was the last day? You pay, let's suppose that you pay $200. I want you guys to figure out what the new statement balance will be. What was how much did we owe straight up before? 844. Wait, was that the average one or the final? Yeah, the final. What was the final number that we owed? 892. That was the last number in our table.
Oh, okay, never mind.
Okay, so we owed 892. We paid 200. Add or subtract? Subtract 200. What about the $14? We add that. That's our penalty for not paying our balance. 1434, I think. This is our new balance. Any questions on that? Okay, so here's what I want to do. We're going to skip 4 temporarily. You guys are going to come back and do that later. Let's jump down to 5 together. We'll go to Lila. Oh, no, Lila, you read already. Yes. Damien. Amortization. Okay, so the basic idea here is that you're not expected to necessarily be able to buy a car with cash or buy a house with cash. So we come up with this really fancy loan where you're going to pay the same amount of money every month, and at the end of a certain period of time, you're going to have that car completely paid for, or the house completely paid for. Is the bank who's giving you this loan going to do that just out of the kindness of their heart?
No.
So if you buy a $5,000 car, is it just going to cost you $5,000 after you pay it off? No, it's going to cost you more. You're going to be paying interest the whole time, right? The moment you sign up for that loan. Same kind of thing for a house. What's a typical term for a mortgage, which is a loan on a house? Like 30 years. 15 years is pretty short term for a mortgage. Like I've heard of 15, 20, and 30 is probably the most common. But 30 years, you're going to be paying off this house. Maybe it's a $200,000 mortgage or something like that. And so over the course of 30 years, you pay the same amount every month, but a lot of that is going to interest, especially in the beginning of this. So the worst formula from the whole semester is right there.
Oh my God.
Barb, number 6, please. Thank you. Okay, so here's the crazy formula. This formula is supposed to allow you to calculate how much you are going to pay per month for your $5,000 car or for your $200,000 house. Okay, this crazy formula with the M over here, M is the monthly payment. All of this other stuff we're just going to plug in. Let's try 7. Sana. Okay, so how much does our car cost? 25,000. Let's suppose that we forget the crazy formula and we forget about interest. That some bank is just going to, out of the kindness of their heart, let us drive off the lot with this $25,000 vehicle and allow us to pay it off over the course of 4 years. How could we figure out the monthly payment assuming no interest? All we're doing is paying $25,000 in equal monthly amounts for 4 years. Okay, so here's the easy but not realistic. 4 times 12, who said that? Was that Barb? What are you counting here, Barb? What is that? Okay, so we're going to make 48 months of payment. Then if they're all going to be equal payments, 25,000 divided by that number. Divided by what? 48 is how much? 520.83. Okay, so every month we write a check for $520.83, and every month we own a little bit more of that car, because when we drive it off the lot, the bank owns the entire car, right? And so every month we're buying a little bit more of that car back from the bank. Okay, again, what's not realistic about this? Nobody's going to do this. The bank is going to go out of business if they don't start collecting some money from us, right? They put the 25,000 out there on the first day. They need to be paid for that service. So the crazy formula we're about to come up with is going to give us the real monthly payment, including the interest. Is it going to be more or less than 520? It's going to be more. We're going to pay some interest. Okay, so let's use the formula. The M stands for monthly payment. That's what we're trying to find. I'm just going to copy it. Equals, which means everything else is going to get replaced with numbers. Okay, P. It's the principal is 25,000. So whatever you pay, whatever the thing costs initially. R, yeah, is the interest rate, 0.0299. Interest rates are almost always as decimals. Divide by 12. Why 12? Yeah, it's cutting the yearly interest rate into 12 equal pieces. Times. 12. Yeah, up there is T, which is the number of months. In just about every other formula, T is in years, but this is a monthly formula. So this calculation Barb had us do before, we needed to do it. It's 48 in this case. Divided by 48, and then subtract 1. Okay. All we need to do is what? We need to use a calculator now. That's all we need to do. The difficulty is that if you get your parentheses in slightly the wrong spots, you're going to get the wrong answer. This is a crazy complicated thing to try to type in one shot. It is possible. I don't recommend it. So I'm going to show you what I recommend, which is to break this up into little bite-sized pieces. Casey, what were you observing? Yeah, Casey's recognizing that this whole thing right here is exactly the same down here. So once we get that number, we can just put it in 2 different places. Good idea. Let's start there. Okay, so I feel like I can type that thing in one shot. Just the thing in yellow. Okay. So parentheses 1 plus 0.0299 divided by 12, close parentheses to the 48. Is that right? Okay. So that number is just going in 2 places. And I'm going to write it, I'm going to round it a little bit when I write it. But then I'm going to show you how to make sure you don't round it when you type it on the calculator. So I'm copying this other stuff. But then instead of this whole thing in yellow, what is it? It's that thing right there. 1.12, we'll say 1.127. I'll just round it right there. Divided by what goes on the bottom? 1.127. And then minus 1. And I have to say that in my mind, that is a whole lot less intimidating than the original. So I really think Casey's suggestion here is a good one. Okay, here's the next thing that I'm going to do. And I recommend you do it this way on the calculator as well. I have rounded this thing pretty abruptly. I got a lot more decimal places there. And when you make rounding errors for something that's spread out over the course of 48 months, which is a long time, they tend to accumulate. So I'm going to show you how to make sure that you don't make any rounding errors, or at least you use your calculator to its fullest potential. What we were trying to do was type in this whole thing that's up there at the top. The next piece of this puzzle that I'm going to type in is this right here. So basically, I'm taking the yellow number and dividing it by the yellow number minus 1, right? And you guys could type that in pretty quickly on your calculator. What's the one place that you got to avoid making an error when you type that in? Something you have to type that is not in that green circle. We need another set of parentheses. Where? Where do we need an extra set of parentheses? On the bottom, because this bottom is two things with the subtraction in between. It's really easy to miss that because you don't have to write it, but you do have to type it. So here's how we're going to type it. We're going to say, okay, if I want that previous answer, on my calculator I have a second, and then there's a button down here that says ANS. And on your scientific calculator, you probably also have a button that says ANS. Stands for the previous answer. And what are we doing with that previous answer? We're dividing it by something. Divided by. Now we type the extra thing, parentheses. Now what did we call, or what is the calculator calling that yellow stuff? It's calling it answer. So I hit second ANS again. Not parentheses yet. What's still on the bottom? Minus 1. Close the parentheses. The hard part of this problem is not using the formula. It's typing the thing into your calculator. That's what makes this challenging. Okay, if you did it right, you should get that. And you used ANS?
I'm doing verbatim. I'm not rounding or anything.
As soon as you type in this 1.1268, you're rounding a little bit.
No, that's the answer before I rounded. I kept its original answer. I didn't round anywhere.
Did you not type this 1.1268 in? Yeah. But you typed it, right?
Yeah.
Yeah.
So it's 6, 7.
Mine says 672.
Where? Here?
And there's a 7 instead of a 4.
At the end.
It's 7.
Yeah. So our calculators round things a little bit differently internally, and maybe my calculator is holding an extra digit that yours isn't, or vice versa. It's not going to make a difference. We're going to round the answer to the nearest penny when all is said and done. But I'm going to store this guy for just a second so I can refer to it later. But I'm going to type in the thing that I wrote up here, the 1.127. If I retype that, let's just see how that compares. 1.127 divided by, well, we can be clever, right? What do you get on the bottom when you subtract? 0.127, right? That's easy. So they're different, right? And that's not a dollar amount yet. We're not up to the dollar amount. We're going to be multiplying something by 25,000 at the end. So that little tiny error in the hundredths place is going to get much bigger. So this is why I'm trying to get us to use the calculator to its fullest potential. It's okay to write things down rounded, but I don't want you to type things in rounded. So try to learn how to use that ANS key. Chad? Yes. So we shouldn't be using it. It's okay. Yeah, it's okay to write it, but we shouldn't be using it. So you should have something very close to this guy if you use the ANS functionality. Okay, so I called it X so I could refer to it. And now I think I'm ready to just start multiplying. 25,000 times the fraction times this answer. 25,000 times the fraction times second answer. So we'll round that to the nearest penny. And as long as you get it right to the nearest penny, then we're fine. And so it's probably possible to just write out all the decimals instead of doing the second answer, but why? It just takes more time. If you understand this idea of second answer, it's actually more accurate and quicker. So I don't know why we wouldn't do it. Okay, so that's it, 553.247, or 0.25, we'll say. So let's bring this guy back. All right, that is our monthly payment compared to 520. The difference is $33. What does that represent? That's the interest. So are we paying $33 altogether for the privilege of getting this car early? How do I find out how much extra it's costing me? Oopsies. Subtract off the 520. So that's the monthly interest times 48 times. So yeah, that's $1,600 in interest plus the 25 grand for the car. And this interest rate is actually pretty low. This is a 3% interest rate. You know, I mean, it's really low. If you change it up to 6%, the numbers are going to get more than twice as bad as they are right now. Questions on that? Okay, so here's what I want you guys to do with your neighbors. You're doing problem number 8 right here. As soon as we have an answer, we'll get it up here and see if everybody's got it right. Then you're going to go back and you're going to do problem number 4 right here. All the parts. We'll get answers up here and people can check their work. And if you finish all that before the end of class, you continue working on the project. Good? Okay, so 8 and then 4, then the project. And I will put flags out right now.